All right, let's do a few more here with I'll use the same functions, good functions to look at. So given f of x is equal to 1 over x minus 1, and g of x is equal to the square root of x. Let's do for part A here. Let's find f composed with g of x. So that'll be f of g of x. Now the nice thing about a problem like this is it's actually a little bit faster than when we had numbers included, because now we're not going to plug in anything into g of x, we're just going to plug g of x into f of x. So f of x is normally 1 over x minus 1, but now I need to replace the x with the square root of x. That's what g of x was, and we can write out that intermediate step if we want. G of x was the square root of x, so I need to plug in the square root of x into f of x. But since there's no numbers involved here, that's it. That's all we need to do on a problem like this. Yeah, let's go ahead and do it the other way around as well. Let's do g composed with f of x. That's going to be g of f of x. And if it helps, go ahead and write in f of x in the inside there. So f of x was 1 over x minus 1. Now we need to plug that into g of x, which was the square root of x. So it's going to be the square root of 1 over x minus 1, which we could simplify to 1 over the square root of x minus 1. You can rationalize that if you want, you don't have to. I might as well go ahead and do it, but MyMathLab will take either answer, but we could rationalize this by multiplying top and bottom by the square root of x minus 1. Either way works there. I will do a few more. I'll rewrite my functions. So I had f of x was the 1 over x minus 1. G of x was the square root of x. Let's say part C, let's find g composed with g of x. So that's going to be g of x, which is going to be g of the square root of x. Now if I plug in the square root of x into g of x, well, g of x is the square root of whatever. In this case, the whatever is the square root of x. And I don't think MyMathLab will be happy with this answer. It might be okay with it, but it might want you to simplify this. So let's go ahead and simplify it. I'm going to use my rational exponents for this. So I know the square root of x is x to the 1/2. But I have another square root on the outside. And then I also know that I can multiply the exponents when I have an exponent to an exponent. 1/2 times 1/2 is 1/4. So you could leave it like this. Or if you prefer root notation, you could say this is the 4th root of x. That would work too. Either way there. And then might as well do f of x. So part D, f composed with f of x. It's going to be f of x. And let's see here, that's the same as saying f of 1 over x minus 1. So now into f, I need to plug in 1 over x minus 1. And then we could simplify this. Simplify it however you'd like. I imagine probably half of you would want to get a common denominator. Maybe the other half would want to just clear the fractions. That's my personal preference, so I'm going to do it that way. I'm going to multiply top and bottom by x minus 1 over x minus 1. I think that's a little bit easier. And you don't have to agree with that. You can certainly get a common denominator instead if you'd like to. On top, 1 times x minus 1 is x minus 1. On the bottom, we have 1 over x minus 1, minus 1, and then I need to distribute the x minus 1 into that. If I do that, let's see here, I will have 1 over x minus 1 times x minus 1, and a negative 1 times x minus 1, which is pretty nice there. These x minus 1s cancel. End up getting x minus 1 on top, 1, and I'm going to distribute that negative sign in, minus x plus 1. So I get x minus 1 over 2 minus x there. that'll do it for this video.